All right, so here is a word scenario that we can create. We'll call word scenarios like story problems, and sometimes they come along with a graph as well. So let's say in this scenario, we're going to a film festival, okay? And you're given the information in writing that you're gonna buy a wristband to get into the festival, so it's a flat fee, okay? And then after you pay that flat fee, you need to pay an additional amount for each movie that you want to see. And let's assume that you don't buy any popcorn or soda. So you're given this graph, and now we're going to have to interpret it, all right? There are a couple things looking at this graph. First of all, you may notice that instead of an X, there's an M, and instead of a Y, there's a C. That's because I want us to get used to not just referring to the horizontal axis as the x-axis, but also any kind of variable that we're looking at that's going to be an independent variable. Likely, just like with the y-axis, it doesn't have to be y as a variable. It could be anything that's dependent upon the independent variable. In this case, we'll call C the total cost, or the total amount of money that we're spending at the film festival. And we're saying that M is the total number of movies that we're going to watch, okay? So if we're given this graph, we should be able to figure out some information. For instance, we should be able to figure out how much that wristband was worth, and we should also be able to figure out how much each additional movie is going to cost. All right. Now, do you see that unlike the tea scenario that we used last time with bottles of tea, this graph does not start at the origin. Do you see that there's nothing here at the origin? Instead, when the x-axis, or the, in this case, m-axis, if we're right on it, there's nothing there, okay? We have to actually go up a bit till we get to $5, all right? Which means this, that our wristband, even if we haven't seen any movies, remember, on this axis right here, we have seen no movies whatsoever. We still need to pay $5. Why? Because it's part of the wristband to get into the movie theater in the first place. So that's how we know that this is our flat fee. What does the intercept of this independent axis mean? It means, in this case, it's the flat fee. Basically, the amount of money that we need to pay just for the right to even see any movies at all, even if we don't choose to see any movies later on. Okay, so this is the wristband. Then each additional movie you see increases how much we're going to have to pay. We should figure out from this graph, if it goes from 0 movies watched, pay $5, 0 movies watched, pay $5. Again, we always put the independent variable first, comma, the dependent variable second. So we go from 0, 5 to, if we watch one movie, then we're going to have to pay $15, okay? So if I pay $15 to watch one movie, but I had to include that $5 of the wristband, how much was the admission of just that one movie? Well, it's 15 minus the cost of the wristband, which is 5, which is 10. So that means a movie itself costs $10. All right, let's go to see 2 movies now. So we need to jump up from paying from $15 right here, and we need to pay $25 right here. So what's the difference between 15 and 25? $10, because I bought another movie, which was $10 worth, all right? So do you see that we're going up by tens? We start at 5, and therefore, since we're going up by the same amount each time, it's going to be a straight line if I connected all of these. It's not going to be a curved line. It's going to be a straight line. Therefore, it's a linear. This is a linear relationship. It's a straight line. Is it proportional? Not proportional. Well, it doesn't go through the origin, okay? The number of iced tea bottles, okay, scenario was proportional, because if I decided to not buy any iced tea models, I wouldn't have to pay any money. That's why it started at the origin. Here, even if I don't watch any movies, even if I have to cut out early, I still need to pay that $5. Therefore, this relationship right here is not proportional. It's linear, but since it doesn't go through the origin, it's not proportional. And also, you can see that the more movies I see, the more money I have to pay. From left to right, it's going up, and so therefore it's increasing. So those are all of the different kinds of analyses we can do by reading whatever that word story problem is and coupling it with the graph.